Slides. Oh. So, good morning, ladies and gentlemen. Thank you for having us here today in this magnificent room. My name is Will Turner, and I'm a researcher at Trinity College, Dublin. And fortunately, my work lead, Professor Basu, couldn't be here today, so I'll be here in his stead, telling you a bit about my involvement in the Indicate project. So, my particular task is to characterise the energy usage of the city. This is task 2.1 in the Indicate project. So I'll briefly tell you about the modelling approach that we're using, the model components we're looking at, then a little bit about the building characterisation, which is our current focus, then mention the city component matrix, which is going to be one of the deliverables towards the Indicate project, and then I'll pose a couple of questions for you guys. So there are three main objectives to the task which I'm working on. First is to characterise the city as an integrated system of component subsystems. The second is to form the basis of a complex system model for the Indicate tool. And then finally aid the development of the 3D dynamic simulation model as the DSM of the city. So the modelling approach we are taking is to represent the city as a system of subsystems. So we have a selection of nodes which represent the energy sinks and the energy sources. Energy sources being power stations, places where energy is generated, such as renewable sites like wind farms, hydroelectric dams, and so on. Then the sinks where the energy is used. So primarily this is buildings, but also transport networks and public services such as lighting, street lighting, and telecoms. And then the energy flows from the sources to the sinks. And this is the most suitable representation in terms of energy modelling. This is the Air Grid National Control Centre in Dublin, where they manage the energy networks in Ireland, and they use a nodal approach. So in terms of the city, we're characterising its energy performance by looking at the different components. So we have the supply side, which is the energy sources. So we're trying to characterise the power stations, distributed energy sources, such as residential photovoltaics and local wind turbines, and also renewable energy sources, such as wind farms, hydroelectric, tidal and solar. Then we're characterising the demand side, so energy sinks, such as buildings, so all buildings, residential, commercial and industrial. Transport networks, such as electric rail, electric vehicles, and also the public services, such as street lighting and telecoms. Then we need to characterise the energy networks, so how the energy flows from the source to the sinks. So in terms of the smart city, there's the electricity network, the transmission lines and substations, and also the gas network. We also need to consider energy storage sites, so bulk storage such as hydroelectric storage, but also smaller scale such as PV batteries in residences and electric vehicle batteries. And then finally, we're characterising the socio-economic side of the smart city. So this is the effect that occupants and users have on the flow of energy around the city by means of time of use tariffs implemented by utility companies and use behaviour inside residences and buildings. So we're looking at lots of different building sources, such as databases from EU projects and building standards and benchmarking systems. So the current focus on the characterization task is on buildings. Why are we concentrating on buildings? Well, EU figures suggest that they make up 40% of the final energy consumption of the EU. And most of that is residential buildings. So again, 75% of the 40% is from residences. The rest is non-residential buildings. And those non-residential buildings are made up primarily from shops and offices. So for our characterization, we're adopting a top-down approach. Typically when you model a building, you're interested in the geometry of the building, the systems inside it, and it takes a lot of time to model a simple building. So modelling buildings on a city scale, you need to cut down a lot of information. So we're using a top-down approach, whereby we classify buildings using certain characteristics based on what we find from the literature. So this is a little bit of the building characterization we're doing. We believe we can define the energy performance of the building with just 4 categories, or 4 property subsets, such as construction, function, geometry, and systems. So construction refers to what the building is made from. Function is what the building is used for. The geometry is the physical space which the building occupies, and systems are the systems or services within the building, such as heating, ventilation, cooling. So once we've characterized all the individual components of the city, we feed them into our city component matrix, which is going to be part of the indicate modeling tool. So as I said before, we're interested in supply side, demand side, energy networks, energy storage, and the socio-economic side. So a couple of questions to you guys, which I'd like to put in your heads before we move on to the next talk. And that is, considering the energy performance of a city, is there anything important missing from this list of our city components? And the second question is that we're currently on a drive for data, data which will enable us to validate our models and validate our characterization. So we're looking for data, sources of available data on city component energy. Thanks very much. Now I'm going to hand you over to Stephen from Future Analytics Consulting.